NEC 2002 Section 300.11 Code states that electrical metallic tubing, or EMT, is not a recognized wiring method in hazardous classified locations. However, a fire pump house is not typically considered a hazardous location. NEC 2002 Section 430.22 states that the service overcurrent protection device must be rated not less than the sum of the lot rotor current of the motor or motors and the full load current of the other equipment. It's possible that the fire pump house is a pre-wired unit that was tested and listed by underwriters' laboratories, or all. In such cases, the wiring within the unit may be considered acceptable by UL even if it does not conform to the letter of the NEC. There may be an exception in Section 300.11 Code that allows EMT to be used in certain limited circumstances, such as within the fire pump house. Also, the local code or ordinance may allow EMT to be used in fire pump houses, even if it is not explicitly permitted by the NEC. It is advisable to consult with the local electrical inspector or fire marshal to determine if EMT is permitted in fire pump houses in your jurisdiction. If there is uncertainty about the UL listing, contact UL directly for clarification on the wiring methods approved for the fire pump house. Check the installation manual for the fire pump house to see if it provides any guidance on the wiring methods used. When dealing with electrical installations, firstly, always prioritize safety. Secondly, strictly adhere to the most current edition of the National Electrical Code, or NEC, unless local amendments dictate otherwise. Thirdly, carefully review the equipment's UL listing and associated documentation. Fourthly, meticulously inspect the installation for any deviations from the NEC or the equipment's listing. Fifthly, if any discrepancies or uncertainties arise, promptly consult with the local authority having jurisdiction, also known as the AHJ, such as an electrical inspector or fire marshal, to ensure compliance and safety. A fire pump controller is a specialized control panel designed to automatically start and operate a fire pump in the event of a fire. It monitors the water pressure in a fire sprinkler system and, upon detecting a pressure drop indicative of a fire, initiates the fire pump to provide the necessary water flow and pressure to suppress the fire. The controller also incorporates various safety features and alarms to ensure reliable and safe operation of the fire pump system. Fire pump controllers are typically required to be listed by a nationally recognized testing laboratory such as UL to ensure compliance with industry standards and safety requirements. The lot rotor current is the current drawn by an alternating current, or AC, motor when it is initially energized and the rotor is not yet rotating. This current is significantly higher than the motor's full load current and can be several times greater. The duration of the lot rotor current is typically short, lasting only a few seconds until the motor reaches its operating speed. The high magnitude of the lot rotor current can cause voltage dips and potential damage to electrical equipment if not properly accounted for in the electrical system design and protection. The full load current of a motor is the current a motor draws when operating at its rated horsepower and voltage under normal operating conditions. This value is typically indicated on the motor's nameplate. The full load current is a crucial parameter for selecting appropriate conductors, overcurrent protection devices, and other electrical components to ensure safe and efficient motor operation. Overcurrent protection devices, such as fuses or circuit breakers, are designed to protect electrical circuits and equipment from excessive current flow that could cause overheating, damage, or fire. These devices are designed to automatically interrupt the circuit when the current exceeds a predetermined level, thereby preventing damage to the protected equipment and minimizing the risk of electrical hazards. Proper selection and coordination of overcurrent protection devices are essential for ensuring the safety and reliability of electrical systems. UL listing is a designation provided by underwriters' laboratories, a nationally recognized testing laboratory indicating that a product has been tested and meets UL safety standards. A UL listing signifies that the product has been evaluated for potential hazards such as fire, electric shock, and mechanical hazards, and that it complies with the applicable safety requirement. UL-listed products are widely accepted and recognized by regulatory authorities, code officials, and consumers as meeting a certain level of safety and performance. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure. The AHA can be a local electrical inspector, fire marshal, building official, or any other entity with the legal authority to enforce codes and standards in a specific jurisdiction. The AHA plays a crucial role in ensuring compliance with safety regulations and standards, and their decisions are typically final and binding. Electrical metallic tubing, or EMT, is a type of thin-walled steel conduit commonly used to protect electrical wiring in buildings and other structures. EMT is lightweight, easy to install, and provides good mechanical protection for conductors. It is typically joined using fittings that are either compression type or set screw type. EMT is not suitable for use in hazardous locations or where exposed to severe physical damage unless properly protected. A hazardous location is an area where fire or explosion hazards may exist due to the presence of flammable gases, vapors, liquids, combustible dusts, or ignitable fibers or flyings. Hazardous locations are classified according to the type and degree of hazard, and special electrical equipment and wiring methods are required to minimize the risk of ignition. The NEC Article 500.5 classifies hazardous locations, with Division 1 being a location where ignitable concentrations of flammable gases, vapors, or liquids exist under normal operating conditions, while Division 2 is a location where ignitable concentrations are present only under abnormal conditions. Class I locations involve flammable gases or vapors, Class Roman II involves combustible dust, and Class Roman III involves ignitable fibers or flyings. Conductors are materials, usually wires or cables, that allow the flow of electrical current. Conductors are typically made of copper or aluminum due to their high conductivity. The size and type of conductor must be carefully selected based on the ampacity requirements of the circuit and the environmental conditions to ensure safe and efficient operation of the electrical system. Ampacity is the current carrying capacity of a conductor expressed in amps. The ampacity of a conductor is determined by its size, material, insulation type, and the ambient temperature. The NEC provides tables and guidelines for determining the appropriate ampacity of conductors based on these factors. Proper selection of conductor ampacity is crucial for preventing overheating and potential fire hazards. In the context of electrical systems, a service refers to the electrical supply from the utility company to a building or structure. The service includes the service entrance conductors, metering equipment, and the main disconnect. The service must be properly sized and installed to meet the electrical demand of the building and to comply with the NEC and local codes. The main disconnect is a switch or circuit breaker that allows the entire electrical service to be disconnected from the building. It is typically located at the point where the service entrance conductors enter the building. The main disconnect provides a means of quickly and safely de-energizing the entire electrical system in case of an emergency or for maintenance purposes. Section 430.22 of the National Electrical Code addresses the minimum ampacity of motor circuit conductors. It mandates that the conductors supplying a single motor must have an ampacity of not less than 125% of the motor's full load current rating. This provision ensures that the conductors are adequately sized to handle the motor's continuous load and any potential overload conditions, preventing overheating and insulation damage. Section 300.11 Cone of the National Electrical Code outlines specific requirements for the support of raceways and cables in electrical installations. It emphasizes that raceways, cable assemblers, boxes, cabinets, and fittings must be securely fastened to the building structure. This requirement is intended to prevent the raceways and cables from sagging, shifting, or becoming damaged, which could compromise the integrity of the electrical system. The exception within Section 300.11 Cone of the National Electrical Code allows for the support of raceways and cables by dedicated support wires or straps under certain conditions. This exception provides flexibility in situations where it may be impractical or unfeasible to directly attach the raceways and cables to the building structure. However, the support wires or straps must be properly sized and installed to provide adequate support and prevent the raceways and cables from sagging or becoming damaged. A fire marshal is a public official responsible for enforcing fire safety codes and regulations. Fire marshals conduct inspections of buildings and facilities to identify fire hazards, investigate fires to determine their cause and origin, and educate the public on fire prevention. They also have the authority to issue citations and orders to correct fire safety violations. A local electrical inspector is a qualified individual responsible for inspecting electrical installations to ensure compliance with the National Electrical Code, local codes, and other applicable regulations. Electrical inspectors review electrical plans, conduct on-site inspections, and issue permits and approvals for electrical work. They play a critical role in ensuring the safety and integrity of electrical systems and preventing electrical hazards. A jockey pump is a small pump used in conjunction with a fire pump system to maintain pressure in the fire sprinkler system when it is not in use. The jockey pump is designed to automatically start and run to compensate for minor pressure losses due to leaks or other factors. This ensures that the fire sprinkler system is always fully charged and ready to operate in the event of a fire. The locked rotor amps, also known as the inrush current, is the maximum current drawn by an electrical motor when it is first started. This current can be significantly higher than the motor's normal running current, typically ranging from 6 to 8 times the full load current. The locked rotor amps must be considered when sizing electrical components such as circuit breakers, fuses, and conductors to ensure that they can handle the high inrush current without tripping or causing damage.